Bismillahirrahmanirrahim. Hi, this is Kashif Anwar, and I am presenting you a new concept of combination circuits. Um, our task is here in the statement. We have two stages. In the first stage, design a combination circuit in order to implement the following function. And what is the function? When an input provided is an even number, one is added in order to convert it into odd number. So whenever the input will be an even number, the output will be an odd number and it will be an increment of its input. No processing is required for odd number. It means that if we give an odd input, the output will be the same and there will be no increment or decrement or anything like that. In example, we can see if the input is a 4, which is an even number, then the output will be a 5. It means it will generate an output equal to 5. Whereas if the odd number is 5, we can say here 5, it will appear on the output as 5. It will have no change. In the second stage, reconstruct the original values that contain odd as well as even values. So whatever the input was, the output should be the same. And how we will do it, we'll see in the coming video. The output provided by the first stage will serve as an input to the stage. The output provided by the first stage will serve as an input to the stage. So the first stage's output, the first stage output will be as an input to this second stage. We come to our protease simulation. Here we can see we are using a keypad small calculator. Why we used this IC? Because we face difficulty in using this calculator directly in our circuit. These two are basically full adders, and we we use them to generate our output. Uh, we have saw our requirements earlier, and now we will apply the same requirements in our stimulation. This is a default case where the first stage, this is the first stage. The first stage, in the first stage, we get an input 0 and output is 1. The first stage output is 1. What does that mean? Does it complete our requirement? The input is an even number and the output should be an increment. It means it should be plus 1. So the input is an even 0 and the output is 1. So it is an increment of 0. We'll see another example. Let's say we give it an input 4, which is an even number. The first stage output gives a 5, which is an increment of 4. Now, last example, we will see an even number 6. So, do we see an increment of that even number? Yes, we see an increment. Let's see an odd number. Let's say 5, in which earlier we saw that if it is a 5, then the output should be a 5 and there should be no change in the first stage output. So there is no change in the first stage output. If we give it 5, it gives out output 5. Now let's come to the second stage from the very start. At the start, it is default input the input is 0, and the second stage gives us same value as input. Now, as we gave 4, it is the same in the second stage. 5, it is same as in as it was in the input. 6, as it is the same in the second stage as it was in the input. So we see that our requirements have fulfilled and both the stages have worked completely perfectly. So this was my presentation. See you next time. Allah Hafiz.